Here's an exam question on algebraic proof. It's only 2 marks, so it shouldn't take us that many steps to get to the answer. N is an integer. Prove algebraically that the sum of half n times n plus 1 and half n plus 1 times n plus 2 is always a square number. So we need to write this sentence mathematically. To be able to do that, let's understand the key terms. So is, and then always a square number. So sum means to add, and we've got 2 terms, and then is, mathematically that means equal to, square number. So we need to end up with something squared in that form. So this is the left-hand side of our argument, and this will be the right-hand side. So I'm going to show you how to start from the left-hand side and then get to the right-hand side, which is something squared. So half n times n plus 1, add n plus 1, n plus 2. So that becomes half n squared plus half n plus half of n squared. So double bracket expansion first. So n times 2, that's 2n. And then we've got another n, so that's 3n. And then plus 2. So that's half n squared plus half n, stays the same. Expanding the brackets there, that's half n squared plus 3 over 2n. So half times 2, that's just 1. Tidying things up, so we've got half n squared plus half n squared, so that's just n squared. And then we've got half n plus 3 over 2n, that's 2n, and then plus 1. So finally, this will become n plus 1, factorizing that becomes n plus 1 all squared. So we're done. We have shown that it's a square number.